All right. Welcome, everybody. Thank you for coming, and thank you for showing up actually on time, which is a miracle given that this is a new time and people may not have necessarily looked very closely at the new time. It's a pleasure to have today with us Dr. Lindsey McGowen from North Carolina State, of course, from main campus. She's from psychology department. She'll be talking about evaluating the impact of cybersecurity science, mixed method approach. Dr. McGowen got a PhD in psychology and public interest from NCSU in 2012. She's a scientist in the Innovation Studies Lab in the psychology department. Her research interests are in program evaluation, innovation studies and implementation studies, collaboration consortium development, program sustainability, and public health. She's currently working as a project manager. She's acting as a project manager for the NSF Industry University Co-op Research Center evaluation project, and she's also working with the NSA Science and Security Lablet here at NC State. For those of you who are not familiar, this is also connected with the LAS lab. And she's also teaching classes in action research and innovation technology. She serves as a center evaluator for 3 NSF UCRC, the Center for Child Injury Prevention Center, the Center for Sustainability Integrated Building and Sites, and the Center for Novel High Voltage Temperature Materials and Structure. She's a member of the AEA and the RTP Evaluators Association and the Society of Community Research in Action, and she's well regarded in her work, and it's a pleasure for me to introduce her.
Thank you. Thank you so much. So I appreciate the introduction. That was very kind. I wanted to come here and talk to you all today about evaluating the impact of cybersecurity science. So this is based on a project that I am working on with some folks here in the computer science department. Dr. Lori Williams and Dr. Maninder Singh have funding from the NSA to do research on how to make cyber systems more secure and how to be more scientific in the way that we approach these problems. And so this research is based on my work with them. So I'll just give you sort of an overview about why it's important to assess the impact of science, technology, and innovation programs, what program evaluation really is, and then I'll give you this sort of case study of the Science of Security Lablet evaluation that we're doing here. I'll talk about what our evaluation strategy is. I'll show you sort of a logic model that we use to structure that evaluation, and then give you some illustrative examples of the data that we've collected in the past year, as well as other metrics and methodology that we're working on going forward. So I probably don't need to convince you all that science, engineering, technology, innovation is important, but it's one of the major drivers of the U.S. economy. We spend billions of dollars on that each year. It's the fastest growing area of the workforce, with computers and mathematical sciences and engineering be the largest growing sector. And academia is really involved in that. We're the second largest conductor of science and engineering research, conducting about 15% of the national total R&D efforts. And there's significant funding and being provided to do this type of work. So what do we get for all of this effort and all this investment? We're using tax dollars to support programs like this, and so it's important to understand what their impact is. And so program evaluation is just a systematic process for answering that question. What are we getting for all this effort and investment? And it may seem pretty clear that the main 2 goals of program evaluation are documenting the impact and demonstrating that you're effective. But it's also useful in as you go along, finding ways to improve so that you are achieving the highest level of effectiveness that you can, as well as identifying what works and what doesn't work so that others who are trying to do the same thing can learn from your efforts. So this is just an example. There's lots of program evaluation going on all across the country, but this is one that's going on here at NC State. So just to give you a little bit of background, the Science and Security Lablet is funded by the NSA. This is their second 3-year award. They get about $2.5 million of funding each year from the NSA to conduct research. There's 4 lablets. There's one here at NC State, and then there's 3 more at University of Illinois, Urbana-Champaign, Carnegie Mellon, and University of Maryland. And each of those lead sites has other collaborating institutions that they work with. And the goal of these lablets is to conduct research around a set of hard problems. So they're focused on 5 hard problems. So human behavior related to cyber systems, how do users, software developers, and attackers affect the security of cyber systems, scalability and composability. So how do you go from one system to protecting multiple connected and network systems, security policies, so how do you develop rules and procedures for making systems more secure, resilient architecture, so again, when you have systems connected, how do you protect those connections so that the system continues to operate even under the face of attack. And that was 4, I'm forgetting one. So anyway, they're working around these 5 hard problems, and they're trying to not only develop solutions to these hard problems, but also to identify, develop, and adopt rigorous methodology around solving these problems. So cyber security and computer science in general is a relatively new field compared to things like biology or physics, and so we're trying to learn as we grow, develop new ways and better ways to understand what are the fundamental principles of a secure cyber system. And then they're trying to develop the community of folks who are focused on these problems and doing research in this way. So they're trying to develop a community of practice. So those are the 3 goals that we're attempting to evaluate based on what our program mission is. So you're trying to solve big problems. You're trying to develop a new scientific approach. You're trying to recruit people into the field. That seems like a lot. So how do you evaluate when you have multiple goals diffused over a long period of time? When you're talking about developing a new scientific approach, that's not a 3-year goal. That's a 10 or a 20-year goal. And these are really long-range objectives. So how do you do that during a 3-year time period of grant funding? So this is an evaluation logic model, and this is how you do it. This is a tool that's used in lots of different types of evaluation, from engineering evaluation, community evaluation, anything. It really just allows you to lay out, here's the problem that we're seeing, here's the steps that we hope to take to solve that problem, and here's some of the sort of things that we hope to see will happen in order to get us to the ultimate impact. So just to sort of outline, if we have a given problem and we use these resources to conduct these activities, this will result in these outputs. If we see these specific outputs, we expect them to have a certain outcome, and we expect those outcomes to ultimately have these impacts. And at each point along a logic model, you can ask evaluation questions. So do we understand the situation correctly? Did we have the resources that we need? Did we conduct the activities that we thought we should conduct? Did those activities produce the outputs that we thought that they should? Did those outputs have the outcome that they should? And what was the ultimate impact of all this effort? And as you're asking these evaluation questions, you're hoping to get to this sort of summative evaluation. So based on all of this, this is what we see that was the ultimate impact of this program. But you can also do, as I mentioned before, formative evaluation, and that's looking at how do we use the feedback that we're getting all along the way to improve as we go. And with a 3-year program with 20-year goals, being able to say, okay, we have the resources, we did the activities, we saw the outputs, allows you to say, look, we may not be able to measure this impact we're trying to have 20 years down the road, but we have confidence that if our assumptions are correct, we're making progress in that direction. So this is a logic model that I put together for the Science of Security Lablet with help from the PIs in that lablet. I don't want to read it all to you, but it basically says that there are significant concerns about security and privacy. We lack the foundational theories to address them. We need more scientifically rigorous methods in order to be able to address these problems, and we need more people working in this area. So in order to address that problem, we've identified some guiding set of hard problems that we're going to focus on. We have a multidisciplinary, multi-institutional team. We're working in world-class research facilities, and we have a lot of funding, infrastructure support to help us do that. Using all those resources, we'll conduct research, we'll provide methodological consulting and oversight, we'll have workshops and seminars, we'll have community building activities, we'll share data, and we'll have real-time evaluation feedback. So if we conduct all those activities, we expect to see that resulting in scientifically rigorous peer-reviewed publications. We expect to see folks attending the workshops and participating in our activities. Hopefully that will lead to new and strengthened connections among researchers in this field, and ultimately scientific and methodological process improvements. We hope that that will allow us to have an impact on the larger field of cybersecurity research. We'll see those principles that we've identified implemented in the design of new systems. We'll see enhanced scientific and technical skills within the community, knowledge diffusion to the security community in general beyond just the academic community, and hopefully that will result in greater national security, more fundamental understanding of cyber systems, and a security community that's poised to address the next challenges. And as you can see, this is involving not just the researchers within the lablet, it's the scientific community, the security community, there's government concerns, as well as the project scientists, students, and public in general. And so with this framework, with these assumptions in place that these various steps will lead one to the next, we can identify metrics along the way. So we have sort of some bean counting metrics for did we have the resources we need, as well as metrics for the activities that we're going to conduct, the outputs. We can measure some of the outcomes, but as we move along the logic model, we're getting into those widely diffused things. So we do a lot of effort to sort of document, here's what we did, here's what it produced, and we expect that those products will lead to these ultimate impacts. And so this sort of time series case study methodology allows you to sort of map your progress along a timeline. So let me just give you some examples of what we're talking about. So I've taken the logic model that I just showed you and broken it down one column per slide. So these were all the inputs that we had, and here are the metrics that we used to measure those. So we have the number of researchers and postdocs and graduate students working on the project, their collaborators, all the different disciplines that they come from. We talk about, when we look at world-class research facilities, NC State is a Research 1 university. That means that we're a highly research-intensive university. Look around you, Centennial campus has a lot of great resources that we're able to use. We also have support in terms of research infrastructure. We have a program coordinator, we have an evaluator, several others, lots of funding. And there's lots of complementary centers and institutes on campus, from LAS to the Research Triangle Park, and then we're able to draw from those resources as well. So I forgot to mention, along the bottom here, you'll see sort of a color coding. I mentioned that the Lablet had 3 objectives, and I sort of tried to color code this table to show which objective each input, activity, output, etc. Is related to. So looking at activities, we've got 13 funded research projects, and we report on the progress of those projects every quarter. We are providing methodological consulting and feedback via some methodology seminars every week. Students that are funded in the Lablet have the opportunity to present a research plan or a paper that they're working on and get feedback from the rest of the folks in the Lablet. During the first year, they had 11 seminars with 18 presentations, and based on feedback from the students who presented, 100% said that they were able to use the feedback that they received to make improvements to their studies. So we know that they're getting that feedback and it's useful to them. Lots of community building activities. So we documented 4 workshops, a community meeting with industry. They formed this new conference, Hot Sauce, Hot Science of Security. So 2 of those have happened. Several quarterly PI meetings have been participated in. So those are the community building activities. We also looked at the publications to identify collaboration with outside researchers. We saw that they were collaborating with 6 funded institutions that had co-authors from 13 other institutions outside of those 6. And we're also planning to, when you publish something, that's the result of a collaboration that's been going on for months or years beforehand. And so we're planning to do some interviews with faculty to identify new and ongoing collaborations. We are also working to help folks share methodology resources, so that we have the Hot Sauce meeting, and so there have been about, at the Hot Sauce meeting, they had the International Research Network for the Science of Security, and that's where they share guidelines, reading lists. They talk about different ways to approach cybersecurity problems. And so we've had about 30 participants in those workshops over the last couple of years. And I've been giving them feedback along the way. So every time they do some kind of activity, we do a survey about that. We give them a report based on how they can improve. Okay, so outputs. If you conduct research, you should be publishing it. So that year, during the 2014-15 academic year, they had 20 publications and presentations, another 9 under review. But as I mentioned, this is the second third-year award. So over the last 4 years, they had 87 publications coming out of this project. We're holding these workshops and these seminars. We're hoping that people are attending them. They are. And we're hoping that they are connecting with each other. We can see that not only in their publications. So when you look at the publications, there's 55 co-authors, but also in the sense of community that they feel that they report when we ask them about that. So 97% of the participants who participated in the Hot Sauce conference felt that it helped build community. 90% met people outside of their working group. We asked industry participants in this conference whether they'd be interested in collaborating with academic researchers. 75% said that they would. And I'll get to this in a minute, but we're planning to do some CV analysis to look at how these collaborations change over time. We're also looking at, based on the methodology feedback that we're providing to students, we're hoping to see that the methods in our studies become more rigorous. And so some folks at the University of Alabama that we're working with are doing an assessment of each of the papers coming out of the Lablet, as well as all the papers from the 2015 IEEE Science, Security, and Privacy to look at their methodology and compare it to the work that we're doing. We're looking at the feedback that the students are receiving as part of the methodology seminars to identify whether or not the studies are becoming more sophisticated. So if you're doing a study and folks are saying, well, I'm not sure what your research question is, I'm not sure what the goal of this study is, we need to improve, you need to become more advanced. As you become more advanced, the feedback might say, you know, I understand the purpose of the study, maybe you want to consider this different type of analysis, or maybe you want to consider this different type of a metric, and that would indicate a more advanced a type of feedback, and therefore a more rigorous type of study. I'm not a computer scientist, though, so when we're talking about process technology improvements, we really need to go to the source. So we're going to be doing interviews with faculty about what is the impact of their work from a technical perspective. Okay, so if those are the sort of outputs, what is the outcome of those outputs? So I'll talk about this in a minute. I'll come back to that. And this is where we start saying, okay, we're not going to be able to measure all of this because we're getting past our 3-year timeline. But we're looking to do some targeted interviews with industry. If we're having an impact on the field, we're hoping to see that come out in the products that are available on the market. So we'll be identifying folks that may be benefiting directly from our work, follow up with them to find out how they're benefiting from that. We're hoping to see enhanced scientific and technical human capital. And I'll talk about more what that means in a minute. But that's basically the skills and the personnel available who've been trained to do research in this way. During the last year, there was 9 PhDs and 3 master's students graduated that were trained in the program, and they've all gone on to take faculty, postdoc, or industry jobs. And the master's students are either working or continuing their research. We'll do some more surveys with students to find out the impact on their skills, their knowledge, their career trajectory. Okay, let's see. So knowledge diffusion to the security community. If you publish something, somebody reads it, they cite it, that's a good way to know that you're having an impact on their work. My understanding of computer science, though, is that it's a very fast-paced field. Citations are a lagging indicator, so we're working on some alternative metrics for that. And we're also hoping to see an increase in the number of researchers. I can't possibly count the number of people doing research across the world in this area, so that's sort of a long-range and diffuse goal. So that was sort of like an all-over-the-place description of all the different metrics we're using, and I want to just sort of focus in on a couple of metrics for each of the goals that we had for this project. So looking at the scholarly outcomes of the research that we had. So this is just a reminder that this is a big project with a lot of goals, a lot of activities, and this is just a metric to assess one small part of that effort. And so we have both quantitative metrics and qualitative approaches. So I'll talk about the quantitative stuff first. So when you're doing evaluation of science and technology programs, there's some established metrics. Bibliometrics is one of those ways. And this is data from a food science evaluation that I did. And so this is the usual way that I might go about, the established sort of way that I would go about assessing the impact of somebody's work. So the Web of Science has journal impact factors. Journal impact factors are based on the average number of citations received by a publication within a 2-year period. And each journal or conference is grouped within a category of similar conferences and journals within the discipline. And so you can say, here's the impact factor of the journals we're publishing in. Here's the impact factor of journals in that category. And you can see that the journals we're publishing in are almost twice as impactful as the average journal in that category. So we know that we're publishing in high-quality journals. Not so fast. For computer science, the existing bibliometric databases are insufficient. So the Web of Science is the most commonly used data source, but computer science researchers typically publish in conferences, and those are severely lacking within the Web of Science. They focus more on journals. They've got a lot of publication venues. When I say publication venues, I'm talking about journals and conferences that are miscategorized. Chemistry journals counted as computer science journals. And as I mentioned before, there's a citation-based indicator, so it's based on the average number of citations to a publication. And that, in computer science, things move really quickly. After a couple of years, things are sort of outdated, and so it's hard to wait that long on a 3-year project to see the impact. Weiner and colleagues did an evaluation of the Web of Science and one other bibliometric database and found that 1/3 to 2/3 of computer science publications are missed in these databases. So we can't use that. However, the science of security involves not only computer science researchers, it also involves psychologists, statisticians, economists. So I wanted to see if maybe it did a little bit better with our work. No. I took a random sample of our publications, and only 26% of them were identified in Scopus. So we need to develop some alternative way of measuring the impact of our scholarly output. Did look around for some other existing databases. They're not there. So we need to identify some other non-citation-based metrics for publication impact or potential impact. So we're working on some alternative metrics. If you look at a publication venue, there's a couple of sort of numbers that you can get from it. We can look at publication selectivity. So out of the total number of publications that were submitted, how many were accepted? And you can look at scale. So how many publications does this venue put out in a year? And so we're going to use those two to evaluate the impact of, or the potential impact of publication venues where our work is appearing. We can also look at co-authorship diversity. So we're trying to do multidisciplinary work, so we can look at the different fields in which co-authors come from, what departments do they come from, and we can show that as a measure of growth in the science of security community of practice. But the main thing that we're working on is a custom bibliometric for the science of security, and that's going to be based on expert evaluation. Expert evaluation is often used in the tenure and review process, sort of an established method. It's recommended by the Computer Research Association as a way to evaluate faculty, and so what we're going to do is develop a list of what are all the relevant publication venues for our work, and then we're going to ask, identify who are the appropriate experts in our field outside the lablet who can rank these publications top tier, second tier, third tier. And then we're going to ask them to actually do that ranking. And that will allow us to demonstrate what percentage of our publications are appearing in top tier venues. And it will also help us improve by allowing us to target our research to the top tier venues. So that's the quantitative work we're doing on scholarly impact assessment. We also have some qualitative efforts. So as I mentioned, we're going to be conducting interviews with faculty. We need to understand the impact of their work. They're the experts. We should ask them. So faculty are already putting together impact summaries, and we're going to build on those to help sort of identify what is the impact of the work, who might be benefiting from the work that we could actually follow up with. So it's not just a self-report impact. We're actually verifying that with outside beneficiaries. And it can also help us to identify collaborations that are not always evident on CVs. As I mentioned, those are also a lagging interview. And so we're working on the interview guides to do those. And just to give you, this is a methodology that we've used for other program evaluations. So just to give you an example of the type of question that we might ask about their work, in your opinion, has your project produced any significant scientific and/or technical results that fill knowledge or research gaps. Please explain in language that a layperson can understand. And then we ask for validation of that impact. Have you received any awards or external recognition for your research? Okay. So we're also, in addition to looking at the impact of their research, we also want to look at the impact of these program activities on their methodology. And so again, a reminder, this is just one part of the overall evaluation that we're doing. So we sort of have two metrics that we're using to assess methodology. So students in the lablet present their research at methodology seminars. They get feedback on their presentations. 90% of those students are actually using that feedback to improve their work. So we're sort of hypothesizing that the feedback that they receive will allow them to improve their methodology, and then that improvement might be reflected in the type of feedback that they receive over time. So if we collect all that feedback, we can do what's called qualitative coding. I don't know if you guys do that, but basically it's taking some text and trying to make sense of it using codes. So you would take a piece of text and you would identify, can we apply a code to this text, and then count, during the first seminar, we saw a lot of feedback about research questions. During the second seminar, we saw more feedback about analysis and results. And so we want to see if the feedback reflects improvement over time. So we're working on that. We're also doing, and this is actually work that's being conducted by Jeff Carver at the University of Alabama. He is doing a rubric-based assessment of the computer science security and the lablet publications. So he just submitted a paper reviewing all of the papers in the 2015 IEEE Science and Security proceedings. Each one of those papers he went through and said, what type of study is this? Is it an experiment? Is it a model? Is it a case study? And then based on what type of study it is, does it include all the elements that we would expect to see in a methodologically rigorous paper based on this type of methodology? And so he's just submitted a paper based on that, which will say, here's the status of the field. These are all good papers. They've all been accepted in one of the top venues in our field. So what is the standard acceptable level of methodological rigor now, based on the various types of studies that are being conducted? And then he's working on a review using the same criteria to evaluate the lablet publications. And so we can say, we're on par with the standard of our field, we're pushing the envelope, we need to improve. What's the case? Okay, so finally the third goal, assessing the community of practice outcomes. And this is really about, so again, one piece of the larger puzzle. So I talked before about scientific and technical human capital. What that means is it's the scientific and technical know-how of people in the field. It's their social capital. So who do they know? Who are they able to work with? Who are they able to connect with to get resources? And the more you know and the more people you know, that's sort of a more mutually reinforcing network. So you learn more people want to work with you. The more you work with others, the more you know. And we expect that to have a mutually reinforcing impact on careers. So we're going to do a couple of metrics to assess the human capital. One is curriculum beta analysis. Again, a CV is a historical document, so it allows me to look at what were you doing before you started participating in this project, what were you doing while you were participating in this project, and what happened after that. So we can look at, is there an increase in the number of co-authors? Is there an increase in the diversity of co-authors? Is there an increase in the diversity in terms of disciplinary as well as institutional co-author diversity? This project isn't really focused on commercialization activities. However, I think that those might be a spillover effect. So we can also look at impacts on patenting and other commercialization activities, as well as funding. So it's not just about publications. So some sample, so those are the sort of the quantitative counts from the CV analysis. We can also look at collaborations in progress. So have you made visits to the lab of scientists at other universities, public firms, to discuss your project-related work? If so, how many? Have they visited you? If so, how often? Have you actually started collaborating with any of those folks that you visited or who have visited you? In terms of career outcomes, we're really looking for students. So we want to know what training opportunities do they participate in. This program has a lot of different training opportunities, but not everyone participates in everything. So we want to understand which ones do they participate, and which one of those training activities has an impact on their career outcomes, so that we can say, folks who did this type of training had these outputs, and we can pass that along. So different training modalities, different opportunities for collaboration. Were they satisfied with those training opportunities? And what impact did it have on their knowledge related to the specific topics of research, their methodological skills, and their skills at working as a member of a team? And then for students, we'll ask them about their career goals. If they're still in school, we can't ask them about their careers. But we're also following students that graduate from the program, ask them about what impact did their training have on their career trajectory, what kind of positions do they hold, how did the training they received prepare them for their current positions. So, comprehensive evaluation. We've got a lot of objectives, and therefore we've got a lot of metrics, and we're talking to a lot of different people as data sources. And so this is really a case study-based approach. We're on site, we're embedded with the researchers, and we're really trying to understand a holistic, comprehensive picture by using multiple different data sources, multiple different metrics, and putting that all together to create a bigger picture, both quantitative and qualitative. What is the impact of this research? And so we're not only trying to measure the impact, we're also trying to help them improve as they go along. And this is really based on some established methodology in the science, technology, and innovation studies field, but we're customizing it for this project. So a lot of this research is developed in collaboration with the folks in the lablets, so I just want to acknowledge their support and their feedback. Any questions or comments?
Thank you.
Thank you.
Are there any questions?
So you talked a lot about different kinds of accounting publications, and it occurred to me that a lot of the computer science things, they might be published or providing toolboxes or providing packages that then could be used by other groups. Are you counting those at all, or are you looking at?
Right. So that'll be part of the faculty interviews. So when you're doing, this is the science of security, so it's not the innovation of security or technology. So we're really expecting to see scientific or academic scholarly output more so than commercial products, but we will definitely include that in our faculty interviews to ask them about sort of those more tangible those products that they might be developing. And when we do the interviews with industry, that will definitely be the focus. Yeah.
Any other questions? I have actually a couple of questions, and the first one actually sort of dovetails precisely with what Eric just asked. It seemed to me, and I may have missed it though, it seemed that you never really talked about or accounted for, rather, the actual performance of the science of security. In other words, how well it actually performs in maintaining, the integrity of, of the cyber network and all that. Or
right. So let me go back here to my logic model. Well, we can see it here. So Impact on enhanced security of U.S. cyber systems. It's a long-range goal. We're focusing on how do we do research on cybersecurity. How do we understand what are the fundamental principles of secure cyber systems? What are the theories and methodology that we would use? So we're talking about, we hope that that will ultimately be the case, but I highly doubt that we will be able to see that kind of impact within a 3-year time frame. So we'll ask about that in the faculty interviews. What is the impact of your work? Tell us how it's impacted cybersecurity in the U.S. But I don't think it's possible to measure that in a quantitative way within a 3-year time frame.
I assume some of the folks that you're working with also are working on algorithm development and things like that to actually address these very problems, right?
Right. So, and that's been the way that computer science works a lot. You know, you have a problem, you develop a solution to that problem, and so the criticism has been that that's sort of a reactive approach. Somebody hacks something, you develop a solution, then there's a new problem, you develop a new solution, and it's you know, sort of very reactive and not a broad approach. So we're trying to develop fundamental theories that can be sort of influencing the research of others, right? So while they do that work, and that may ultimately be the ultimate goal, that may not be the immediate outputs that they're producing related to this project.
The other question I have is, okay, so you develop all this sort of theoretical framework to assess, you know, or to evaluate whether the science of cybersecurity and all. How do you evaluate your evaluation?
Right. So we can look at comparison groups. So compared to other students in cybersecurity who aren't, or in computer science who aren't part of the lablet, what does their career trajectory look like compared to our students' career trajectory? We can do the same thing with the curriculum beta analysis. The bibliometric approach that I had originally proposed, where you compare journals that you're publishing in to journals in other categories, that's a good sort of control group. We're not going to have that in this because it's so customized. But when you're not able to do an experiment, have real randomization and real control groups, you have to use something like this, a logic model, to say, you know, this is what we think will happen, this is why we think it will happen, and you sort of use measured counterfactuals to determine whether or not what you're doing had the impact or if it was something else. So.
Right. Are there any other questions? All right. If not, let's thank our speaker.
Thank you. Appreciate you all coming out.
Thank you.